Good afternoon. My name is Mikołaj Matyaszewski, Director of Business Development at Northeastern University's Institute for Experiential AI. As you can imagine, since late last year, our partners have come to us frequently with questions about generative AI. Tools like ChatGPT have illustrated the potential of AI in an accessible way, which has captured the public's attention as well as the interest of the business world. But it's just one type of AI, a subset of a subset. For many, it has created more questions than answers. Our partners are asking us, which types of problems can be solved by tools like this? And for which types of problems am I better off investing in other solutions? Or how can I use this technology ethically and responsibly? Most of all, they want to know how to separate hype from the real promise. Today, we have three pioneers of data and AI to help demystify generative AI and turn it into something you can use to innovate. Dr. Usama Fayyad is the Executive Director of the Institute for Experiential AI at Northeastern University and Professor of the Practice at Corey College of Computer Science. He also serves as Chairman of Open Insights, a technology and consulting firm he founded in 2008 after leaving Yahoo, where he served as the company's first Chief Data Officer and founded Yahoo Research Labs. Fayyad's previous roles include Global Chief Data Officer at Barclays Bank and Founding Executive Chairman at Oasis 500. He has held leadership roles at Microsoft and founded the Machine Learning Systems Group at NASA's Jet Propulsion Laboratory, where his work on machine learning resulted in the Top Excellence in Research Award from Caltech and a U.S. government medal from NASA. Dr. Kenneth Church is Professor of the Practice at the Corey College of Computer Sciences at Northeastern University. His research focuses on natural language processing and information retrieval, artificial intelligence, and machine learning. Before joining Northeastern in 2022, Church worked as a scientist at Baidu, a researcher at IBM, and a scientist at Johns Hopkins University. He was recognized as a Baidu Fellow in 2018, an Association for Computational Linguistics Fellow in 2015, and served as president of ACL in 2012. Dr. Ricardo Baeza-Yates is the Director of Research and co-leader of the Responsible AI practice at the Institute for Experiential AI. He joined the Institute for Experiential AI after his role as Chief Technology Officer for Intent, a semantic search company based in California. Before his role as CTO for Intent, Ricardo was VP of Research for Yahoo Labs from 2006 to 2014, at which point he became Chief Research Scientist at the company's headquarters in Sunnyvale, California, until 2016. Baeza-Yates actively participates as an expert in many global initiatives, committees, and advisory boards related to responsible AI. These include the ACM Technology Policy Committee, IEEE Ethics Committee, and the Global Partnership on AI. He is on the editorial committee of the New AI and Ethics Journal and co-author of an article highlighting the importance of research freedom on ethical AI titled Towards Intellectual Freedom in an AI Ethics Global Community, and the co-chair of the AI Ethics Advisory Board at the Institute for Experiential AI. Here to begin is Dr. Usama Fayyad, Executive Director of the Institute for Experiential AI.
Welcome everyone, and thank you for joining us. My job today will be to do some quick introductory remarks, give an overview of the technology and where it's used in business, give a rough idea of the things to watch out for when you use it, but we will let Ken go into the details of how the algorithms work so that we can demystify some of this technology a bit and make it more understandable and more reachable. And then Ricardo will join and cover what to watch out for when you use this technology and the traps that are out there and how to use it properly. So with that, what is generative AI? Well, it's a generation of text, images, etc. from textual or multimodal prompt. So if you're generating text from a large language model, we call that basically text LLMs. These models are sometimes referred to as stochastic parrots, technically, and I like that term because it reflects correctly the fact that they do not understand what they say. They are doing a very fancy type of autocomplete, and if it's trained properly, they can do a good job of that. But there is no semantic understanding of what's going on. Other models, of course, if you're not using text, could generate images, videos, lately sounds, voices, etc. Examples for text is ChatGPT from OpenAI, Bard from Google, and so forth, Llama from Meta or Facebook. Images, there's DALL-E, also from OpenAI, Stable Diffusion, Midjourney, short videos, code. One of my favorite examples is Copilot, which was built on the GitHub code base at Microsoft. And then, of course, there's voice and music. So with that, I want to say a few words. One word on generative AI. It actually refers to algorithms that generate data as part of their operations, as part of their training. And because they can generate data, we can leverage that to make them essentially produce things that may look like new. They're dependent on two major developments: transformers, which I'm sure we'll hear a lot more about from Ken, which are deep neural nets that map words and phrases into embeddings in a large vector space, and attention, which is a way to track a certain keyword across multiple pages or multiple documents. Earlier versions of this technology used to use the generative adversarial networks. Over time, people replaced that systematically with human intervention and human adversarial. And that's really primarily to improve and take care of all the corner cases that these algorithms fall into, pointing the need for human intervention. ChatGPT is just an interface, a chat interface that would put on top of GPT-3 initially, then 3.5, now 4.0. GPT stands for Generative Pre-trained Transformer Model, and utilizes the transformer I referred to in the case of GPT, current versions of GPT. It's about 1 terabyte of data that was very carefully curated, cleaned up, balanced, muting a lot of the hate speech in it and a lot of the bad stuff you see on the internet, etc., and then using some safe sources where no bad stuff can be in it. It uses the generative supervised training that we talked about, and it's really essentially trying to predict what is the next token in the sequence. They're important to say that the capabilities underneath have been around. GPT-3 has been around since 2020. It just captured attention once we put the chat interface and made it easy for people to use. I often refer to it as autocomplete on steroids, but it does produce interesting results, as the world knows now. This is essentially an example of what we call a large language model, and more on that from Ken later in this talk. The hype of improvements, these things have improved dramatically. In the pre-2000, I would say, handwriting recognition took a long time, and so did face recognition and so forth, to improve slowly, incrementally, etc. We seem to have hit, and Ken will talk about this, a discontinuity where some of these improvements can happen fairly quickly, primarily because we can leverage a heck of a lot more data and many more complex models than we did before. And we've come up with ways for training these large language models, as an example. So you can see from the graphs, some of these most recent ones, the improvements have been dramatic and sudden, which is also why it's been catching the world by surprise. Speed of adoption has also been amazing. If you look at Google Translate, it took about 78 months to reach 100 million users, right? Uber took 70 months, and so forth, all the way down to ChatGPT, which effectively broke records by reaching 100 million users in 2 months, which hence a lot of the hype and the interest. Is there a human in the loop in this operation? Yes, I refer here to an article, a nice article that actually makes it explainable why there are humans. Sometimes they answer the questions. Sometimes they get brought in when the technology starts going awry. Now, not to put this down, we actually think this is a very good practice. In fact, it's a best practice. We call it Experiential AI, for AI with the human in the loop. It is used in many technologies, including Google MLR, the machine learned relevance, page ranking, Amazon recommendations, and many intervention-based relevance feedback systems that have been around in information retrieval for a long time. As I move forward, the other thing to point out is there is a business model, right? GPT-3 is not free. OpenAI was founded in 2015. 2019, Microsoft invested about $1 billion on top of another similar amount by other earlier investors. In 2023, there was another $10 billion, it is thought, that was injected. I actually think the big impacts here are not the embedding in Bing, which is happening, but really when it opens up in MS Office like Outlook, PowerPoint, Word, etc. There is a cost to using, for example, GPT-3. You can specialize it if you want to pay for that. And they charge by the character for you to specialize it. So if you have a certain body of text, a set of documents that are proprietary, and you want to increment the knowledge of GPT-3, for example, or now hopefully 3.5, unclear on 4.0, you actually submit those documents, it gets retrained, and you get charged. To give you an example of this, this is before the major price reduction that happened recently on GPT-3 in particular, not 3.5 and 4. A corpus of data of about, this is coming from Sam Scarpino at the Institute, 65,000 docs, in this case, each one about 10,000 characters long, training for 4 epochs, which just means how many cycles. Cost is about 50K. Now what happened is there was a major price reduction, thankfully, on GPT-3. 3.5 and 4 are still very expensive. So the thing to remember is it's not free if you want to use it commercially, and there is a business behind it. As I advance forward, there's many possible uses of generative AI. You could use it in finance, in many different functions, monitor transactions in the context of individual history, build better fraud detection systems. Legal firms can use it to design and interpret contracts, come up with the first version of many agreements. Manufacturers can combine data from cameras and x-rays and other metrics to identify defects and root causes more accurately. Again, if you have examples of this happening, both images and their outcomes. Film and media produce content more economically and translate into other languages in the actor's own voices. Medical industry, identify promising drug efficiencies. For example, find diagnoses that are based on rare diseases, things that the medical professional may have not thought of. Again, always in the form of suggestions. Architectural firms design and adapt prototypes faster, gaming companies to come up with scripts, and so forth. Many uses. There are some very simple, safe uses, like correcting and improving the content and style of any communication, mail, documents, ads, etc. It's pretty good at that if you want standardized and if you're willing to clean up after it. Extracting information from documents, i.e. summarizing, debugging code, as we mentioned, used in Copilot by Microsoft. Programming non-critical components, if you're willing to go into the code and make sure it's doing the right thing. And use it as a teacher where you learn something through a conversation. Think of it as a personalized teacher. Generate prompts to be used for tools that can generate audio, images, etc. And finally, find information on a topic. It doesn't give sources, but at least you'll know what is known out there if it was trained. And by the way, one of the issues is how recently is the data, how recent is the data fed in? So for example, GPT-4 is not good on recent data. It doesn't know the recent news, etc. I'm sure over time this will get fixed. The economic impact though is for knowledge worker tasks. There's several estimates ranging from 50% to 80%. I fall on the 80% of the work that is done by a knowledge worker that is likely to experience significant acceleration, meaning you get to a start point much faster, much better. But the total automation is not in reach. And it's not, and I don't believe it should be a goal necessarily, but if you're thinking about completely automating a job, you can't. But you can accelerate it significantly, and 80% is nothing to sneeze at. You need the human in the loop to check the output, to go in and edit it and modify it and approve it. One of the things to remember about the stochastic parrots, they don't have any reasoning capabilities. They don't have common sense reasoning even. So once they go off, and you'll see examples of that with Ricardo, they really go off the path. I often get asked this question, and I'll conclude with this remark. Will AI replace my job? The eternal question I'm getting these days. My answer has become no, absolutely not. AI will not replace your job. A human using AI will actually replace your job if you are not using AI. So with that, I'm going to turn it over to my colleague, Ken, to continue from here.
All right, so will deep nets solve my use case? Well, some problems are more promising and some are less promising. And the more promising ones are similar to something that we've studied a lot and have lots of promising solutions on the hubs. So what do I mean by the hubs? Well, here are two examples. Hugging Face is a popular one in much of the world. Paddle is something similar in China. These are repositories for sharing data sets, models, and tutorials. So a data set has a bunch of inputs X and outputs Y. We'll see some examples of that. A model would be something like F. It could be pre-trained or post-trained. We'll explain what that means in a minute. And F would take an input X and produce an output label Y. And then there's lots of tutorials on how to use this. There are 27,000 data sets on Hugging Face last I looked. It's increasing extremely quickly, and there are even more models there. And much of this is freeware. The best is very good, but community-supported stuff is catch as catch can. Now, there are lots and lots of applications. Usama mentioned many of them. Let me talk a little bit about some more practical ones on the right. Imagine a machine is listening to an outbound telemarketing call and wants to predict the chance of a sale in the near future. I think of this a little bit like a focus group with politicians wanting to know how their candidate's doing during a debate. On the bottom, we have more elusive cases. One case I've been asked is, could I take an input of arbitrary a news article and decide whether it's got insight, yes or no? Reminds me of a high school teacher I had who would, when she got frustrated with us, would tell us to be intelligent. Who knows what that is? It's very difficult to classify who knows what without some kind of training data. And even then, it's got to be something which is sort of more concrete. So here's some examples of training data. For a sentiment task, you could have an input like I love you or I hate you, and then have some labels like positive or negative. We need some examples like this for any task we're looking at. For outbound telemarketing, I'd have one audio that maybe in a couple days after the audio, a sale shows up in the database, and another audio where I look in the database even weeks later and there's no sale. We'll talk about a flowers example where we have various pictures of different scenes, and there would be labels like tulip or daisy. And I mentioned the more elusive cases where you have a URL. One URL is labeled insightful and another one's labeled as lacks insight. And this may be very difficult because even the judges don't agree with each other. So I gave a tutorial recently at a conference on this, and we talked about all the things deep nets can do, but also lots of things that we still need to work on. And the tutorial has lots of examples at that link. So there's a standard three-step recipe. I'll talk about all 3 steps, but let's start on the easy one, that is this inference. This runs very quickly and you don't need a lot of hardware. It's very cheap and we should be able to do this. So for example, if I give you an input string, say, I love you, it would output a label positive, and then it would have a very good score. This is kind of an easy case. Now there are lots of models F, as I mentioned, and some of them do say sentiment, that's this task. There's other tasks we can talk about, like fake news or spam detection. So here's an example of I love you. I just grabbed a bunch of models off the hub, and many of them produce good results. This one could be more confident. This is a two-way forced choice. Sometimes the labels are positive and negative. Sometimes there may be 1 to 5 stars. Now, here's some examples where it doesn't work so well. For fake news, it seems to be saying this is all fake news. Now, I put in red some cautionary notes. It's important to use a model that's appropriate for the task. If you've got a model that was trained for a Chinese task and I give it some English input, who knows what you're going to get. Ditto for Spanish. And for the spam ham thing, we use something that's probably not very appropriate as well. Now, there are, as I said, lots and lots of tasks. The sort of fundamental thing that these are really good at is filling in the mask. So if I say, I mask you, love is high on the list. It's not the top of the list, but it's high up there. And say, if I love the mask guy, you get some other choices. And this is a much longer list. The top choice is not nearly so confident. Pizza is only 3% as opposed to 30% for miss. Here are lots of examples of machine translation, and the hub has 2,000 examples of different models for this, mostly for different language combinations. So let's talk about one of the harder steps, pre-training. And in this case, I'm going to suggest that we should just let the big industrial labs do this. It's too expensive for most of us to do. Now, why do I say that? Well, over the last 5 years, the number of parameters has been going up and up and up. And here's a plot of that same data. And along with the parameters goes cost, the size of the data center, the number of authors on a paper. Just everywhere you look at it, the investments are going up. So why are the investments going up? Well, because it seems that as with much larger investments, you see good returns. This is showing performance is improving with the size of the models. And what I'm going to observe is that many of these best models show up on the hubs or on the APIs, and we should just wait for that to happen. And so this rising tide lifts all boats. So I would say here it's better to just follow the leaders. It's not necessary to be the leader here. So let's talk about the middle case. The middle case is somewhere in between easy and hard. And so here's an example of fine tuning. That's the middle case. So you start with a pre-trained model, a very expensive model you can get from a hub or an API. You add some data to it, and then you get a post-trained model. So I'm going to talk about an example. Imagine that I wanted to build a wildfire guide where you could take a camera, your phone, take a picture of whatever you see, and then it would take you to the relevant page in the guide. Now, let me start with a pre-trained model, ResNet. ResNet was trained on 14 million images, and it outputs 1,000 classes, but it doesn't output these 1,000 classes. Then I have a small data set, which I'll call flowers. It's got 2,000 pictures of flowers, and it outputs just 5 classes, tulip through rose. And so now, after I do the pre-training, the fine-tuning, I end up with a post-trained model that takes an arbitrary picture of anything and would output 1 of 5 strings. So if you took a picture of any of these kinds of flowers, you'd probably get taken to the right page in the guide. But if you take a picture of anything else, it will take you to one of these 5 pages, because this classifier knows how to classify any picture into these 5 labels and nothing else. So let's go back to this question, will DeepNet solve my problem? And we're saying one of the important things is that you need to have training data that's easy to find, easy to annotate, and the judges would agree with one another. And say the elusive cases are maybe where the judges don't agree. What's got insight, what doesn't have insight. But I think the judges would agree on which pictures are which flowers. So imagine we were to go back to this practical use case. you've got an outbound telemarketing call, or you want to know how the politician's doing. Imagine I'm the outbound telemarketing business. I have lots of audio calls and I have a database of sales. So this kind of training data should be pretty easy to come by. When you've got that, we're in good shape. As Ricardo's going to say, you can enter these prompts and it gives you back pretty interesting answers. Prompt engineering is find valuable prompts that solve a real information need. Prompt engineering is like fine tuning, but doesn't require as much access to the model. It's likely to replace the fine tuning because the pre-trained model is becoming bigger and more expensive, and as a consequence, the industry that's invested in all these things are less likely to share it. So they're not going to give you the same hub access. You'll have to access it through an API. And so prompt engineering is the only option. So is the glass half full, half empty? About 10 years ago or so, I wrote a paper called "The Pendulum Swung Too Far." We see AI winters often follow periods of irrational exuberance. It's like the excitement with deep nets. We tend to be impressed by people that speak well or write well. When the machine is extremely fluent, it makes us think that it's well read, and people who are well read tend to be successful. Now that machines are better than people on many tasks, say spelling correction, now they're better at fluency, we tend to believe that means that they're smarter than we are. But I think there'll be an AI winter when disappointment sets in and people realize that fluency is not the same thing as intelligence. And we'll get to that in a minute. But the machines now speak too confidently about stuff they just don't know what they're talking about. So back when I wrote that paper, we were in the middle of a period of rapid change. Between the 90s and the next 10 years, there were almost no statistical papers at the beginning of that period. At the end of that period, they were all statistical, and people thought this is the way it was going to be. Now, what we're seeing over that red line on the right is showing that was a very myopic view. If we look at a larger time frame, we see that between over the 50s and 50 years after that, the things come and go. And what I think was going on is that in the 50s, empiricism was all the rage with people like Shannon and so on. And 20 years later, it was different, and 20 years later, it went back to empiricism. What's going on here? Well, the mechanism is that grandparents and grandchildren have a natural alliance. My teachers rebelled against their teachers, and my generation returned the favor. Now, the strengths and weaknesses are that the strengths are the things we were good at in the 50s and the 90s, and the weaknesses are the things that my teachers were worried about. We tend to think that, we made so much progress on fluency that everything will follow. But in fact, my generation went back to empiricism because we were finding the problems that our teachers were working on were too hard. We knew that machines could make real progress on fluency, but the things that our teachers worked on, that's really hard, and we're still stuck there. Let me talk about hallucinations. So our teachers were very interested in negation. You say a robin is a fill in the blank, it gets bird, excellent. Now you say a robin is not a, it still gets bird. There aren't many things that would be wrong here, but bird is one of them. And the reason for that is because synonyms and antonyms are all going to co-occur in text. So let's talk about hallucinations. The language models tend to make up alternative facts faster than they'd be fact-checked. This is a very dangerous failure mode. People are likely to believe these alternative facts. So here's an example that happened on 60 Minutes just a week or two ago. Leslie Stahl, the reporter, asked, "Who is Leslie Stahl?" And the system came back with a pretty good answer that she really didn't like. So she highlighted in yellow this hallucination. To us, maybe NBC, CBS, it's all the same thing, but to her, it's a terrible error to accuse her of working for the competition. This was on CBS, not on NBC. That's a really serious error. one error like that can get your product canceled. So just to conclude, will deep nets solve my problem? There are more promising cases, less promising cases. And what I want to say is that I've got a whole bunch of examples here. We talked about some, didn't talk about all of them, but among hallucinations, robustness is absolutely critical. One serious computer error like this, your product gets canceled. So thank you.
So let me continue with the dangers of generative AI. So Ken was talking about the hallucinations, and he had an example about what is the highest altitude capital in Europe. And I don't know if you had time to read it, but basically you didn't get the right answer at the beginning. So you see here it's saying that it's La Paz, Bolivia, which we all know is in South America, and the system knows that. So you wonder why start with that answer, and then gives the right answer, which is Andorra. It's a very small landlocked country between Spain and France in the Pyrenees. But then you get also the second highest that was not part of the question, but that answer is wrong. So it's not Bern, the second highest. We'll get back to this. Or for example, if you ask how many continents are on Earth, and this depends if you come from Europe or if you have the North American view where America is 2 continents. Well, for example, here it's in English, and if you see, you get North and South America. But now if I ask in Spanish, I hope you can understand this, you get America as a single continent, and then you get Australia and Oceania, that basically they're the same continent. And I guess this is to keep the number at 7, although the real number should be 6. So again, there is no knowledge base behind this system, so you get these incoherent answers. Now, if we do the same question in Spanish, I will translate it for you because it's really hallucinating. Says, again at the beginning, that the highest capital in Europe is La Paz in Bolivia, that knows that Bolivia is not geographically in Europe, but invents the following. But it's part of the European continent culturally and politically. So basically makes the answer to fit that is Bolivia. So it's also very easy to manipulate this system. So for example, this is the new version, doesn't give the right answer again. So it says that it's Madrid, in the capital of Spain. But then you ask, what is the altitude of Andorra? Because that's the right answer. So it gives the right altitude. And then it says that it's the highest capital city in Europe. So contradicts itself with the previous answer. But then I ask again, and seems to remember that now Andorra is the right one. And you ask, okay, well, why you answer first Madrid? And then it merely apologizes. So basically, it's very easy to not only convince the system that it was wrong, but also you can lie to the system. For example, here I tell the system that the truth is that Tbilisi, which is the capital of Georgia, not in the Caucasus, is the highest. Of course, this is a lie, it's not true, but apologize again, and then thank you, and it answers now that this is the highest. But this is a lie. And also, for example, here I tell them that the second one is Yerevan in Armenia, but close to Georgia. That's another lie, and the system believes that. So this is one of the problems. Not only hallucinates, but also believes what you say. So if we could think that this is a human, of course, not a human, we have a very confident person, but also it's very naive because basically everything you tell the system will believe you. And then you will have a lot of incoherence. So it doesn't have like a memory state of what has answered and how things are changing. And then in some sense, you can think that it's drug because it's hallucinating. So one problem in the long term, when we have, for example, many people using this and putting more content in the web, basically it will be very hard to know which content is true, which content is false, and then also which content is human, because we should learn only from human content. And this is a problem that basically the web is getting polluted by hallucinations that will also basically harm the learning of these systems. And let me give you a personal example. This started in LinkedIn. In February, some Brazilian asked for top AI researchers that died in the last 20 years. This is the answer in Portuguese. And the surprise is that I appear there. So I'm not Brazilian, but the system knows that. But he says that it's included in the list because I work in these two places, the Federal University of Minas Gerais. I had never worked there. And second, Yahoo Research Brazil. Well, Usama started Yahoo Research. We had Yahoo Research Latin America. We had Yahoo Research Europe, but never we had Yahoo Research Brazil. So people will believe these things because the only expert on my life is myself. So that's very hard to check if something's true or not. And that happens with many, many contents in these systems. Now, of course, I was curious how I died, right? I'm sure anyone will do this. So I checked what the system knew about myself. I appear in Wikipedia, so it's not strange that it knows my biography. But when you start checking it, well, there are many false statements. So here I won a prize that I haven't, and then that I died in 2021 at the age of 55. So I believe I'm still alive, and basically the age is wrong too. So although it has the right birth date, so it doesn't know how to compute the difference between 2 years. And I wanted to know how I died. So didn't know exactly, but says he passed away due to complications related to cancer. Well, you know, cancer is the most probable cause of death today if you don't die by being old. And then I said, okay, can you point me one of these reports that mention my death? Basically couldn't, but invented things that could make sense, that the ACM, I'm an ACM fellow, so did something, and also that the Chilean Computer Science Society did something. So that might be true, but was never true. So it makes sense, but it's not true. And also I checked, okay, how the system may have thought about me being dead. Well, there was another Ricardo Baeza, doesn't have the same surname as I have, but he died in 2021. Maybe here gets confused, and of course doesn't know that there are people with the same name and so on. So this is like a new Babel tower. Why? Because before we had this kind of penalty that we had different languages, and then was more difficult to communicate. But now it's even worse, because if you get different answers in different languages, we have different knowledges. So it will be very hard to know who is saying the truth, especially if they get the truth between quotes from the same source, for example, a chatbot. And if you use images, Usama mentioned this at the beginning, I think fiction is easy to recognize. For example, this is a classical example of Dali, of an astronaut in a horse with a space background. Well, you can ask the opposite, and you get this, and of course you will say, this is not true. This cannot happen, right? So there's a complete other problem here of intellectual property. Artists are not happy with this. When we can say that this is plagiarism or not, this is not yet solved, but it's a problem. But the reality gets much more complicated. I'm sure you have seen in the last weeks these kind of images that look very realistic, but they are not true. So the Pope, for example, wearing fancy dresses and shoes, or for example, Trump being taken by the police before he going to court in New York. So imagine now with videos. Imagine that you can take any person with the right voice, like they did with Val Kilmer in the recent Maverick movie, and then you basically put any message you want in that person talking in the video. This is scary, and it's already very close to be true, and will be very hard to know if something is true or not. So here is the intellectual property issue. Very recently, last month, the Copyright Office of the US did some guidance on what things can be copyrighted if they come from AI or not. So here is the reference. You can check it. It's very easy to find. But then you have some bad uses already of these technologies. And this is also very recently, Europol, at the beginning of this month, put a report. It's a public report. Europol is the union of all the policies of the European Union. And basically, what is the impact of ChatGPT in law enforcement? And they basically recall cases of fraud, of impersonation, of social engineering, basically getting data from you, so of course, cybercrime, and even they go to not being transparent when the system is very similar to a human. So, for example, one important thing in all of your products, if you are using AI, the user should know that it's talking to an AI-based product. So when you have transparency, it's already a problem. But this gets more scary. In March 28, there was a newspaper article in Belgium that maybe is the first casualty of the bad use of a chatbot. So what happened? This was a person that was a PhD student, so not any person, with a wife and 2 kids. After 6 months talking to a chatbot, one called ChatJ from the company Elixir AI, committed suicide. And of course, the person had some mental issues. And you might say, okay, this person will get suicide anyway, but depends. If you talk to a counselor, if you talk to, in this case, with your wife, maybe the thing will be different. But when you see the last conversation, it's really scary. I will give you time to read it. It looks like a science fiction movie, but it's the last conversation, and you can assess yourself if the chat bot helped or not him to take the decision. Yeah, I'm sure you are thinking about this. So before that, just 1 week before, although it went in the news after this Belgium case, there was a letter from the Future of Life Institute that asked for a moratorium of 6 months for everything, including research. At that time, when I took this, the only 1,000 signatures. Today, I think there's like 26,000 signatures. The reasons are not very good because they're based on AGI. So basically that a super intelligent being will appear and that will destroy humankind. But also there are some ethical issues on the Future of Life Institute that basically is this thing about long-termism and effective altruism that in many cases have been used to basically scam people and not really to do good for humanity. Gary Marcus, if you follow him, is one of the people that covered this case. And basically, the hype is, okay, we are in the AGI risk. No, we are here in the AI risk. The risk of the example I just showed that happened in Belgium, or people, for example, training a system to talk to a dead person using all their messages and so on. This is the system. And there was a very interesting article in The Guardian with Jason Lanier that he said that one problem is not that AI will destroy us. The problem is that will make us insane. So the real risk, and here I would recommend to follow Narayanan and Kapoor. They have this newsletter called AI Snake Oil. And also talking about this letter, these are the speculative risks, like malicious disinformation, jobs replacing, Usama talked about that, long-term existential risk. But here are the real risk, basically overconfidence over inaccurate tools, centralized power, and near-term security risk. And here again is the hype, how these things have grown, for example, in a start history of all these models. So it's going really fast. But then there were many developments after all these things that were happening, especially in Europe. And for example, the first thing that happened in the US was this complaint to the Federal Trade Commission by the Center for AI and Digital Policy, basically to OpenAI for violating Section 5 of the FTC Act, and also the recent guidance for AI products that basically say in 2 words or 3 words, you shouldn't deceive the user. April 1st is not a joke, it's because that's the first day. ChatGPT was banned in Italy over privacy concerns. So basically using GDPR, the directive for data protection in the European Union. And very recently, only April 4, China published for comments the first full regulation for generative AI. This was published 1 day later, like in April 12 by Stanford and other sites, the translation, that has very harsh measures on generative AI. So this is very interesting that China is the first one that is doing this. Now, if we go to what is happening in the US with responsible AI, we need to recall in October 4, the publishing of this blueprint for an AI Bill of Rights. It's not really an AI Bill of Rights because it's not for people, it's for developers. And basically it's pushing for these 5 principles in software development. So safe and effective systems, no discrimination, data privacy, notice and explanation, and the human in the loop that Usama mentioned. Just 2 weeks later, in the ACM, as Miklos mentioned, I'm part of the US ACM Technology Policy Committee. We published this set of principles. I'm one of the main 2 authors of this list of principles, and I'm highlighting in red the ones that are really important. And the first one, and maybe is the most important, is a new, and this is one that I propose, is called legitimacy and competence. Basically, before you do anything, you need to prove that your system is ethically and legally legitimate, and also you have all the competence to do that. Particularly, you have the permission of whoever has to give you permission to do it, because there are some serious cases. For example, the whole government of Netherlands resigned because basically someone did something at the low level in ministry that shouldn't do, and then that caused a ripple of effects that basically put the whole government in a very weak position that had to resign. That happened in January 2021, if you want to check the news. So these principles alone are useless. Even each one alone is useless. So you need to understand the governance of them. So you start with an idea, then you need to apply the first legitimacy and competence principle. Then if you go to design, develop, and operate the system, you need to use almost all of them, from minimizing harm to limiting environmental impacts. But then you have the things that you need to use when the system basically starts failing. For example, contestability and auditability. Contestability will be human in the loop. Auditability will be the ability to audit the system and to see how it's working. And if it harms, we need to do accountability and responsibility. And of course, we have things that we can use for this. From the first one, you have ethical risk assessment or human rights risk assessment if we don't agree on what is ethics. Then you can do validation and testing. Of course, here we need to do much more because we haven't developed responsible software engineering that much. And then you can have monitoring tools on operation. For example, how difficult it was to monitor the conversation of this person during the 6 months, to not see that the conversation was going in the wrong way and basically was pushing this person to a suicide. And when it fails, we can do a really audit. We can also help on this if needed. So this is our responsible AI practice. We have 3 branches: governance, the most important one I just mentioned. Then we can do this AI ethics risk analysis for any product, any project, any idea, to do this legitimacy and competence assessment. And then, of course, we can train people, because if people don't understand how to use these ideas from the engineering to the C-level, we cannot do much. And something also very important that we did last July, because there are cases where there are not enough experts and you need like a global view, we created the first worldwide AI ethics advisory board that is receiving basically private requests from any institution if you have a problem where you don't know exactly how to solve the ethical conflict that you have. So thank you.
Thank you to our experts and to our audience. Today, we hope to have given you the tools you need to begin to filter out the hype, determine which of your problems are the best candidates for a large language model, and integrate a responsible approach into your AI strategy. But these are not objectives which can be accomplished in one webinar. And so we encourage you to reach out through our contact page, email address, or multiple social media channels. For now, let's turn it over to questions from the audience. Please submit any questions you have into the questions box. Thank you. All right, so we actually got way too many questions for the 10 minutes we have left. Keep putting them in, because what we'll do is add them to a list that we then reply to the audience with. So all your questions are going to get answered after the show. But for now, we have a few good questions that we can answer live. So first, Ricardo, very glad to see you're still with us, even though ChatGPT informed us of your death. So while that might be a darkly comic example, it's easy to see how such misinformation might have serious impacts to a business making critical investment decisions, or maybe to a company whose products affect people's health and safety. So if a business adopts large language models to help with decision making, how can they help themselves identify when the tools are hallucinating or spewing out misinformation?
Thank you, Miklos. That's a very good question. It's very hard because, as I said in the presentation, this system don't have a knowledge base behind. So they are not able to check themselves if something is true or not. We could build another model that, for example, using information from the web, tries to decide what is false and what is not, and that can be done. But the best solution will be to really have a knowledge base behind to check these facts. But very few companies have knowledge base that are large enough, open domain, that they can check everything. And basically, with more expertise you need to understand the content, more difficult will be to check these facts.
Thanks a lot. Our next question comes from Frederick R. And this one's for Ken. So Ken, you have a long experience working with in applications such as customer care systems. Chatbots have historically had a terrible reputation among consumers. Do you think the excitement over LLMs will generate into real adoption based on their increased fluency, or are there ingredients still missing for consumers to accept and trust the technology?
Yeah, well, that's actually a great question. I actually think that the success or not of a customer care app has more to do with the incentives in the business than with the technology. So let me give an example. There's something we all use, and it works so well, people probably just forget about it. It's called a CAN, or card activation number. When you get a credit card in the mail, you routinely have to call an 800 number and activate it, or go on a website and activate it. And Penny, the woman who invented this method, was doing this for very good reason. Large numbers of credit cards are being stolen from the post office, and this basically stopped it. And she came up with a very simple, old-style script that used, press 1 for this and 2 for that, and it just worked. This is a great example where the incentives all make a lot of sense. It solved a problem, and it's relatively painless. Penny is a real interesting character. The marketing people wanted to abuse this service and start spamming all these people with pitches for offers that didn't make any sense. And Penny put her foot down on this, and for some strange reason, the executives actually supported her, and that saved us from that catastrophe. Now, examples where it doesn't work well are where the business doesn't want to talk to its customers. So generally, these chatbots and IVRs and so on, they all work pretty well when the business wants to talk to its customers, but they don't work so well when it doesn't. Some of the best examples would be government bureaucracies, who the only people that call this bureaucracy are people that don't vote. These people get terrible service, and actually it'd probably be better just to hang up on these people than what we do to them. But IVR can be, and all this technology can be used to help a business that doesn't want to listen to its customers. And I think that's the fundamental problem with the chatbots that have a bad reputation, is they're largely being deployed in applications where the business doesn't want to listen to its customers. And that's a kind of crazy business. But I think in a business where the business really does want to talk to its customers and really does want to understand what they have to say, the technology can actually be quite useful and quite helpful. And it's being deployed in those cases, but you only tend to remember the bad experiences. You don't remember the good ones. So people who probably use card activation numbers all the time, they probably use ATMs all the time. These things work so smoothly, you don't remember them. It's when the chat box is being rude to you because it's being run by a business that doesn't want to listen to you, that's when it's unpleasant.
Thanks. Yeah, that makes a lot of sense. Ultimately it comes down to the attitude and the humans behind the technology rather than the technology itself.
Exactly. And the incentives are the reasons for that. Yeah.
All right, we have time for one more question. This one comes from Adriana Yu. How could ChatGPT and other transformers influence the learning and teaching system? And which could be some possible future positive repercussions on businesses? I'll start with Ricardo, and then Ken, you might have something to add.
Yeah, that's a very good question. I think we need to embrace these technologies in spite that they cause a little bit of trouble in education. For example, I like this example where a teacher said to the students, you have to use ChatGPT, and then you have to check everything that is not true. So changing the way of thinking, and then basically do critical thinking, which is what we want to teach to our students. So we need to deal with that. We need maybe to change, and we have done that in the past. So with the calculator happened the same, with the computer happened the same. So I think we can adapt, but we haven't seen all the possible uses of these technologies in so many different ways. So we will see more surprises in the future. So Ken, I'm sure you have something to add.
Yeah, so I think of these things as like a thesaurus on steroids. So good writers use thesauruses. So what I would say is that students should be encouraged to use ChatGPT, but not only do the fact checking that Ricardo did, but say, get maybe a dozen different answers, and then try to get the best of each of them and see what it's good at and what it's not good at. So I think it's actually better than most of us at fluency and worse than most of us on content. And I would say that a thesaurus is probably better than we are at fluency. It knows how to pick the right verbs, or at least it suggests lots of words, some of which are really right for what we want, and some of them are just not right for what we want. And so I see an author's job as being a little bit more like an editor. That is, you can take lots of candidates and then try to mash them up into an answer that's better than any of them, and also, of course, be more accurate. So I think there are ways to use this as a human in the loop that would actually be productive and would actually train people to be better writers. I think this could be particularly useful for students who are, maybe younger students who don't have the vocabulary. Could also be very useful for second language learners who may not be that fluent in a second language.
All right. Thank you both so much. That's all the time we have for now, but we will be sharing this recording with our audience, and we'll be able to answer all the questions that we got when we share that recording. One thing to note that I saw for any students using ChatGPT, I saw a photo on LinkedIn today, and the first sentence of the essay was, I am a generative AI model. So make sure you delete the first part of the question or the first part of the response.
No, I think that's okay. That's transparency.
Okay, fair enough.
Quote your sources, yes.
Excellent. So thank you very much, everyone. The next time you can interact with the Institute for Experiential AI will be April 25th, next Tuesday, for our event Generative AI in Northeastern University from the Classroom to the Economy. The registration link is in the chat. Again, we will be sharing the full recording after. So thank you all so much and have a wonderful end of your week.
Join Northeastern University experts in person or online for a vital conversation about how generative AI is changing, how we teach, how we work, and more. On Tuesday, April 25th, 2023 from 8:30 to 11 a.m. at Egan Research Center, the Raytheon Amphitheater in Boston, Massachusetts, or online.